Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. Thank you for taking the time out to listen to our show about electric vehicle technology. There is a huge amount of legislative change going on globally relating to vehicle emissions. Too much to get it all into one podcast. So I'm just going to talk today about Europe and about the changes that have been made recently and further changes that are coming. So we've seen a lot of announcements by car manufacturers in the last 6 months relating to electrifying their products. This is potentially great news for the environment and the market, but what are the real drivers behind this? There are basically two connected but very different environmental drivers behind these changes. The first is air quality. In the wake of Dieselgate, it was made clear that the legislation to limit toxic exhaust emissions, such as NOx and particulates, was not having the desired effect in practice. At the best case, this was due to testing methods that did not replicate real-world driving conditions and allowed the emissions to be cycle optimized to pass the test, but be miles off in actual real-world driving. And in the worst case, as we all know, this allowed car manufacturers to detect when the vehicle was actually on the test and modify the engine performance to cheat. The fallout from this led to a much harder testing regime being introduced. In the first instance, the WLTP cycle was introduced in 2018, then moving to what is called Real Driving Environment or RDE testing in 2019. These test methods will be applied to both the exhaust emissions and also used for CO2 ratings in the future to avoid any future cycle optimizing jiggery-pokery as has taken place in the past. So it means that all the toxic stuff that's bad for our health, like NOx and PMs, as well as the climate changing stuff, CO2, is measured in the most representative manner possible. The opportunity in these new test methods is that under the past old NEDC cycle, there's a number of innovations that could have led to real-world emissions and fuel economy benefits, but these were not adopted by manufacturers as they did not show a benefit on the testing cycle. I've personally been frustrated by this in the past when we've been working with car manufacturers to look at improving efficiency, but if the innovation or the technology that was being proposed didn't show a benefit on this very non-representative NEDC cycle, then it would be very, very unlikely to make it into production. This would be particularly, in my experience, around thermal management and optimization, because in the old tests, these were carried out in a temperature-controlled lab and the car was conditioned before taking part in the test. Whereas now, achieving compliance has to be demonstrated in a huge range of driving conditions, subject to the full range of temperatures expected, and basically everything that a normal car would go through when it's being used within Europe. Also, another area critical for consideration is demonstrating compliance over the life of the vehicle. So this has been a huge problem as well, and it's still, to be honest, quite a big issue with internal combustion engine vehicles, in that the ability to test those vehicles in the life of the vehicles doesn't match the testing that's carried out when the vehicle is first launched into the market. But achieving compliance for the exhaust emissions regulations through the life of the vehicle is really, really important, and there's been lots of changes around that. So achieving compliance under the new test regimes is really difficult compared to the old test regimes, and that's actually led to some vehicles being withdrawn completely from the market, and then some significant investments in engine and powertrain upgrades on others. Now, if that wasn't enough to be getting on with, the other thing the industry is having to deal with right now is the new regulations for mandatory fleet CO2 reductions. So in December 2018, the European Commission agreed new mandatory targets for CO2 reduction for manufacturers who sell vehicles within Europe. This is a figure that's calculated based on the previously mentioned test results, and then an average is taken across all the vehicles that the manufacturer sells. The new targets set by the EU call for a 15% reduction in CO2 emissions by 2025, and a massive jump of another 22.5% to give a total improvement of 37.5% by 2030. And this is all in comparison to the 2021 figures. This also applies to light commercial vehicles, so vans up to 3.5 tonnes, where a slightly different set of targets of 15% by 2025 and then a jump to 31% by 2030 apply. So these are really big, really ambitious targets, and they're specifically designed to move the industry towards zero emission or ultra low emission vehicles. A special incentive multiplier of 1.85 is applied on any zero emission vehicles sold. This is up to a certain amount of constraints, and there's some caps on this, basically to prevent people from making special compliance vehicles. But there's a clear incentive there to go to zero emission technology. By the way, there's no preference on what that technology is. It could be fuel cells, it could be batteries. The Commission hasn't specified one or the other, but they have been very clear that you will get some bonus points for selling zero emission vehicles into the marketplace. The other compounding problem with these targets is that consumers have been typically moving from smaller, more fuel-efficient cars to larger, less efficient SUVs. So if your sales of SUVs with higher than your fleet average emissions is going up, it's going to be even harder to meet these targets for reducing overall fleet CO2 moving forwards. Compliance with these new regulations goes in some way to explain the slew of announcements from car manufacturers who are having to come up with complete new powertrain strategies in order to meet this change in legislation. So an easy way to achieve compliance would be to shift entirely to electric powertrain. So one company, for example, that's not going to have any problem whatsoever meeting these targets is Tesla. But this would be a massive gamble for the traditional car makers. Will they be able to get the costs and the performance to a point that their customers will accept? And what if a competitor makes a way of making a super cheap combustion engine car that delivers the fleet requirements that the EU have set, and they can meet the targets and steal the market? So this is a massive high-stakes game we're talking about here, and it's a fight for survival of some of the car makers in the huge European market. So what does this mean in practice? I think by 2025, most, if not all, cars will have to be mild hybrid, and even today there was an announcement of another new mild hybrid coming to the market. But beyond the basic mild hybrid technology, they will also have to have a significant level of powertrain electrification. So many of these will be using an electric motor to assist the engine and recover energy under braking. So we all know how that works. These are going to be bigger hybrid systems than the current ones on the market. So currently it's between sort of 7.5 and 15 kilowatts in the market, belt drive starter generators. We're expecting powers between 15 and 20 kilowatts for these new electrical machines. And typically that's not going to be belt driven. It's going to be integrated into the transmission or into the engine in a more effective way. And then also, in addition to that main electrical machine helping the engine out and recovering energy, there's also going to be all of the high power accessory systems on the engine powered from this same 48 volt system, such as the cooling fans, the coolant pumps, and the air conditioning compressor. So this mild hybrid system serves two purposes. First of all, the parasitic power consumption on the engine can be reduced and an amount of energy can be recovered, giving a good base CO2 benefit. And secondly, the thermal management of the engine can be greatly optimized, giving a real-world emissions improvement. This can be done through improved control of the pumps and fans, and also by using the torque, positive or negative, from the electric motor to shift the engine around in its operating curve. So we talk at Avid about these systems as being Generation 2 mild hybrids, and the CO2 savings that you would typically get from that across a range of driving would be 15 to 20%. And I know we've done some work on trucks, which some of you might have seen, and we were getting kind of mid-20s, 25 to 28%. Now, the important thing there is that was a really that was an urban driving cycle that we were using. So under a wider range of operating conditions, including more high-speed driving, that's going to come down. So around 15 to 20% is possible with a Gen 2 mild hybrid technology. So, mild hybrids combined with a relatively low number of full electric or plug-in vehicles should get manufacturers past that 15% hurdle for 2025. But clearly more is going to be needed to get the additional 22.5% reduction required by 2030. And this is where the need for larger volumes of battery electric and plug-in hybrids come from. So if we take the assumption that further advances in combustion systems and engine technology are going to be really limited to low single-digit efficiency improvements, then you can basically work back from there the number of battery electric and plug-in hybrids that need to be in each manufacturer's fleet by 2030. Now, being tactical with the vehicles that are turned into battery electric can also help. So, for example, if you've got a mix of high-performance sports cars that emit way above your fleet CO2 average, it would make a lot of sense to turn all of these into battery electric or at least plug-in hybrids. You could have fuel cells in there as well, by the way. I'm not exclusively wed to battery electrics, but you get my point. So if you take those higher performance vehicles in your model range and you make those zero emission or plug-in hybrid, so zero emission capable, ultra low emission vehicles, you're going to be in with a fighting chance. And you can see that starting to happen now, coming through in the market. So some manufacturers, BMW, for example, announcing that their new X3 is going to be battery electric only, and all of their M cars will all be plug-in hybrid. Now, by the way, BMW has also said that all of its cars will be at least a mild hybrid. The head of Powertrain said that at a conference in October last year. You've also got Porsche announcing that the next Macan will be battery electric only. So a bit like with the mild hybrid technology, the plug-in hybrid systems will see electrified engine ancillaries as well, providing CO2 reduction, and they will also play a central role in real-world emissions compliance, like we said earlier with the mild hybrid systems. The smart move to have the biggest impact on average CO2 is to look at those vehicles with the worst emissions. It's very simple analysis. You pick the biggest variances and you attack those first. Conveniently, we know electrification is great for performance. All that low-speed torque makes for a great driving experience. There's issues around ride and handling for sure with a big heavy battery pack in a full EV, battery EV. So, that's where you might see the plug-in hybrids coming in, or possibly even fuel cells in that respect. But, we do know we can make a very, very good high-performance EV right now. And we're going to see lots of those coming. We've seen what can be done from some manufacturers. We're going to see lots and lots of those coming. In addition, on the other reason for kind of cracking the high performance vehicles is that low volume, so these things tend to be made in lower volumes than the mass market, mid-market products. Low volume, high performance internal combustion engine powertrains are really, really expensive to develop and to manufacture. So a lot of the times when we're looking at the delta in cost between an electric powertrain and a mass manufactured gasoline or diesel engine powertrain, it's really hard to compete with those mechanical engines when they're made in very, very high volumes. But in the lower volume, higher performance product, there's a bit more to play with because the manufacturing costs are higher on the internal combustion engine products relative to their high volume products. So there also tends to be better margins on these vehicles as well. So, we can absorb the cost of more electrification in the powertrain. And really, if you're buying an M3 or really a high performance vehicle, you're buying it for the performance. So do you really care about the cost? I think you probably do a little bit, but it's not going to be your main driver. So we're going to see a lot of that. The final piece of the puzzle, though, is that even within the EU, we've got harmonized standards. There are regions acting independently, and they're making moves towards zero emission zones or bans on the sale of new petrol and diesel cars. For example, the Netherlands, recently Ireland, Sweden, Denmark, Israel, not in Europe, but very closely linked to Europe. They've all announced bans on the sale of non-zero emission vehicles from 2030. So that's within the timeline that we're looking at here. Then the UK, France, and China are aiming for 2040. So that's at a country level, but then drill down another level. There's about 30 cities around the world that have announced their intentions to ban non-zero emission vehicles from within the cities within the next 10 or 15 years. So, that could be really, really bad news. In a funny sort of way, I think the bans help vehicle manufacturers as there's just absolute clarity on what they need to do without an outright ban. There's a bigger risk for the vehicle manufacturer. It's a really difficult balancing act of technology, of investment, of market acceptance, and the risk that a competitor might find a better way than you have to deliver a more cost-effective solution. So I think in a funny sort of way, although they're potentially a massive pain in the butt, these outright bans do make the situation clearer and more obvious when Sims what to do. And again, people haven't said it has to be battery electric in those cases. It just has to be zero emission from the vehicle. So other technologies that can deliver that would also be applicable. So we can see from this, there's huge changes going on. There's lots of announcements coming up. To me, particularly the announcements on the additional CO2 reductions that popped through in December, that kind of went under the radar. It wasn't massively out there in the press. It seemed to me that the announcements from manufacturers seemed to be getting much more coverage, and we weren't really thinking about the why. So, there is a reason why people are saying all my cars are going to be electric cars or electrified cars. I don't really like that term, electrified. Well, it's a mild hybrid right up to a full battery electric. So this is why, to achieve these really challenging new test regimes for real driving environment, emissions compliance, and also meet these really, really tough, huge CO2 reduction targets, efficiency targets that are coming from the EU. So massive, massive amount of work to do there. So I've got a lot of predictions, but here are my top 5 predictions for powertrain strategy in the light-duty market in the coming decade. So my number 1 prediction is that 48-volt mild hybrids will be really, really important. These will go beyond the simple front-end belt drive to include fully electrified engine ancillary systems that deliver real-world CO2 and emissions benefits. There will be a lot of these in the mass market through 2025. And whilst it might seem counterintuitive, these vehicles are a really good way to get some benefits without adding huge cost or complexity to the vehicles. And also just things like the infrastructure for dealing with full battery electric. So we can get some pretty significant benefits from mild hybrid. And we're going to see that going all the way through 2025, and as much as 85% of the market, I think, will still be combustion engine, but with a 48-volt mild hybrid system to support it and to help it achieve CO2 reduction and achieve improved performance from an emissions point of view under real driving conditions. So my number 2 prediction is that OEMs will increasingly adopt more plug-in hybrid and battery electric vehicles to their fleet. And because of the maths, both on how the CO2 emissions are calculated and the real-world emissions compliance and the costs and the margins on these systems, a big portion of this is going to be on higher performance vehicles and SUVs. So expect to see high-performance battery electric and plug-in hybrid vehicle launches between now and 2025 on high-performance vehicles and SUVs. You're going to see absolutely loads of those, I think. So manufacturers strategically thinking about how to take out the worst offenders in their model lineups will give them a benefit across their range. So next, at number 3, there's also going to be a lot of BEVs at the other end of the spectrum in the city car, city van niche to fill the need for vehicles that need to deliver in zero emission zones, and also to replace the current diesel super minis that have delivered much of the emissions reduction to date. So that's the other thing to take into account here, is that so far a lot of the emissions reductions have come from very fuel efficient diesel super minis. Making those diesel super minis compliant with the emissions regs under real driving environment testings is really tough, really expensive. It's very hard to package the after treatment systems in that are required. So I think we're going to see a lot of battery electric city type cars. So, more Renault Zoes. We've already seen announcements. PSA have got one coming. Opel, Vauxhall have got one coming. There's going to be a lot of those. I've got to say, we now have in our family a Zoe, and it's absolutely fantastic. And we're going to see a lot of those cars on the market. The other thing that I think we're going to see, so my fourth prediction, is that more cities will announce zero emission zones in some shape or form. And basically this is going to happen once the politicians see that it can be done and they realise that it's a vote winner as well as a lifesaver. So at the minute, I think there's a lot of places that are thinking about it, but the politicians are nervous about doing it because they're worried about public backlash. Oh, what am I going to do with my whatever? I think when they start to see it happen and start to see the real benefits that come from these zones, they're going to be almost a bit of a landslide effect, which could pull a lot of the timing further forwards. So that's my fourth prediction. We're going to see more small-scale action taken by cities and municipalities on zero emission zones. So fifth and final prediction, battery cost is going to keep on coming down and the performance is going to keep on increasing in terms of improved energy density and improved durability. And it's going to get to a point where somewhere between 2025 and 2030, many, many more vehicles will be able to cost effectively move to battery electric. And I think that's going to displace quite a few plug-in hybrid and mild hybrid sales. I think the OEMs are going to have to work really hard on this to get their battery supply chains under control, and the use of more costly additives, and to be honest, some more dubious ones from a sort of ethics point of view, such as cobalt, are going to be all but eliminated by 2030 due to fundamental improvements in underlying chemistry and battery technology. So things coming into the market, such as solid state, which are going to help us get away from these more racy and harder to deliver battery chemistries. So that's all I've got time for today, and I really hope you found this useful. If you have enjoyed the show, it would mean the absolute world to me if you could leave us a rating and hit like. Don't forget to subscribe to make sure you get more shows in the future. And also don't forget there's a growing back catalogue of Avid Technology podcasts, interviews and conference speeches that you can find in all of the usual podcast places that you go to. And we've also got some great videos on our YouTube channel. We've just launched a new one a couple of days ago. So don't forget to check that out. Videos showing things in animation and film that we can't get across on a podcast like this. So I really look forward to speaking to you again very, very soon. Thanks for taking the time to listen to us today.